Good morning, everyone. It's been a while since I posted videos on my work lately, and I've been, the same symphony, busy with loads of stuff, family, life, business, whatever. This video I decided to, about a month ago, I decided to uh, wanted to do some work on the Kronos or continue work on the Kronos. Even though I've got my montage over there, I love it. Obviously some teething problems. Probably will be software updates later on, but that's fine. Um, it's not fair that we started this Kronos work and I kind of almost dished it in the way because there's various reasons for that. Mainly because I've got my music making machine, which I love, and I don't need this anymore. And I actually never needed it anyway. Never liked it, but deep inside, I had this urge to have a challenge and the reverse engineering of it, and then understanding what how it works and how the things were made, and maybe one day I can make my own instrument. So that is one thing. But I think almost a year ago, it was getting to a stage where it's hard to talk about something when you know that something is probably going to breach copyrights or do some stuff. And I'm trying to get away from that. But the more feedback I get about Korg kind of dropping the support for the instrument and not, I would say, caring about people having it. Um, I don't know. I mean, if Korg is going to release a new instrument sooner or later, or maybe they decided not to because of the fine they get. I think they got about 1.5 million fine a couple of years ago for breaching, trading standard. I think something like that in the UK. That's not the point. The issue is, I think I do want to kind of continue working on this now. I think um, the problem I have is the time. So I don't think it's fair to kind of press me on the time because it's not a paid project. I only do it when I feel like it. It's not something I being pushed to come up with and you know do updates and stuff like that. But who knows? Maybe one day we'll have a working release that people might like. But I mean, bear in mind this instrument's about what 10, 12 years old, and the chances are there will be an update or replacement, probably by Korg or someone else. So yeah, I mean, we trying to obviously my aim is to dig behind the technology and understand what's happening in the back scenes and maybe show that. It's not My aim isn't to make you use files and copyrighted material and then kind of breach that. That's not my aim. My aim is to kind of I love technology. I love machine coding. I love that kind of stuff. That's something I enjoy, but not in a way to kind of hurt other people who worked hard for their stuff. And you can probably see it's been 10 years I think since I last left it or something. I never breached any copyrights. I never did anything wrong with it. It's just I got fed up with its with stuff online. But anyway, so yeah, let's enough talk. Let's get started. So I'm gonna power up the instrument. Obviously, I did progress a lot, and the thing is, I did not do much work for the past year, other than I think what is this? About a month ago, I posted online on my Facebook page that I am looking forward to get back to the work on Kronos, and then just to see how this is gonna go. So yeah. Anyway, so this is my the OS menu. I hope the other camera that I'm actually got here can pick up the stuff. I'm trying to record 4K. I'm using a DJI this time to record the screens. It's hard to adjust because they've got the lighting on that side. They got the camera on that side, so I'm trying to get the camera not to appear in the frame. So anyway, yeah. The other bit is don't ask me about why that thing on my shirt. Here we go. It's 3:15 a.m. I can't be asked to go and change it now, so bear with me. Anyway, let's. By the way, these are the times I recompiled the OS. You got loads of things there, and I'm just gonna walk you through what is happening at the moment. So if I start the thingy, what I've done is logging lots of stuff on the OS side. There, you can see it. By the way, my favorite Linux. Yeah, anyway, so yeah. Okay, so last time what we did, I think a year ago, I posted a thing on communication. What we did, I exposed the communication between the Kronos and the PC, and I did have a problem, whereas um, when it powers up, it doesn't, it goes all the way, you get the screens, but the whole thing just stops and it doesn't carry on. I've progressed from that point since then, and I made another compilation of the OS. So if I just go into the, by the way, this here you'll see is a lot of things being displayed on the screen, and what I'm trying to show you here. Let me see if I can capture that. Yeah, so here you have the maybe that's a better view hopefully than this one, but we'll compare later. So you see any module trying to load up, I actually use the OS to kind of recompile or to tell it to every time the module is trying to do something, I want to know about it. So load module, so for example the loading sections, the KA, the other stuff. And so every time the instrument wants to do something, I want to know about it. And here is you've probably seen this in my last video. This is the logging codes for the instrument. So anything the OMAP and PC are talking about is actually listed here. So in a way, if you can grab these codes up, then you can definitely make a similar instrument at some point. Oh, sorry, no, let me rephrase that. You can probably control the instrument from another interface, and that's one of the stuff I've actually been looking into. So anyway, the system is powering up now. You can see this is one of the negative side of the Kronos, the booting up sequence. So you try to power up the instrument, and by the time it boots up, the idea in your head to make music is gone because it takes forever. Anyway, so nearly we're getting there. Just to power things up. It's just painful to watch it booting up. I don't like that. And to be honest with you, I did something on that side, and I will share later. The main thing is I don't know if I can fit everything in this video. So I have this one to begin with. God knows I tried to record this about 4 times. Every time I do, something happens. And, I started over the weekend and, doorbell rang, people come in, loads of stuff happened. So anyway, tried to do that yesterday, didn't work. I just didn't like the angles and the cameras and stuff. So, change that now, get a better thing. And the other thing is, if the video is not enough, I probably will split it, and my next video, or this video hopefully, will talk about the communication that actually managed to grab. There's a whole other topic. I don't want to do too much on that. So this video is pretty much to recap and to talk about stuff on the OS side. In particular, the loading of items. So now you can see this is pretty much my own OS, not the original Kronos OS. So what you can see here is all the codes displayed, you know, how things talk to each other, etc., etc. So all that stuff is done. For example, if I wanted to do the tempo change, you know, it all listed here, and so on. So what I wanted to talk about today is how this has all been loaded, and you know, the stuff I talked about 10 years ago. So now let's look into, get back the Kronos shell. So we got my shell back, and we got the instrument working out fine, nicely. And you can see it's responsive. You got the lights, you know, the heartbeat of the tempo coming up, and you know, you can press things and the instrument will work fine. You can see that there. You can change different things on the screen. The issue is I need to give the foreground process so that the whole thing will pick up. So yeah, exactly. And this is, yeah, let's just wait for it. You see what's happening there? When I press some keys, and the system is actually the shell is in the foreground, the instrument is doing stuff, but it's not really 100% responsive. So you can see what's happening in the background. It's loading up. So now you see when I click the button here. So if I click on the third item, it's trying to change it. That's because it's loading up all the sounds. It's doing all that stuff in here. And yeah. So you see now, because I have a lot going on, the URB status of the callback is not able to cope, because I'm actually logging so much on the screen, and the screen is considered a bit slow. So what's happening right now is the device kind of died because of my logging so much, and that's one of the things I'm actually working on at the moment. It's not this. If I remove these logs, everything will work fine, and the USB would be even much quicker to respond. That's what the issue is at the moment. So just going to reboot the instrument, but you can see my point. I've powered up the instrument, and when I ask it to when I ask the shell to come back and to get out of EVA, the response has changed. The instrument no longer, the interface, in particular the menus on the system, when I click any button, it just queued it up and didn't do that instantly. Which is my next topic now. So, if I take you to the other side. So now we're going to reload the instrument in a slightly different way, slightly quicker way. You might laugh at this in the end, but yeah. Okay. Good. So now you're going to power up the instrument, but notice this time the loading time will be a lot quicker than before, and you'll see why in a minute. By the way, that bit here, the added KL symbols, is because I actually got lots of debugging information. So just that side here will take about 26 seconds. This is because I'm actually doing something there. So that's, just ignore that bit. But you can start from here. So this is the bit when you power up the instrument. This is when your instrument will start. And you can see, notice when I get to the middle, that's going to come up quite quicker. The red bit, see that now? Yep. See? The power up of the instrument is going to be about 5 seconds or less. There, it's up. There. The instrument now is working fine. Also the same thing, you got the menus, you got the stuff, but, big but. Why did it work quicker? Is because the instrument has failed to load the preload.ksc file. So in other words, what I have done myself onto this version of the OS, that's this, notice when I first loaded up, it was fine. Now I'm loading up, it's not fine, because I actually told the OS this time to load to give the only 1 GB for the upper memory for this to load. So what that means is the preload.ksc has no room to load, which is fine, and that's why the whole thing is shifted quicker. Now, brings me, this is, you might think, yeah, it's a bit dumb to say because, yeah, no memory, no load, but the interesting part, and this is where things got me started making me think a little bit more. And I said this 10 years ago. If the instrument is loading things up, and if the OMAP is the only guy responsible for making the sound and doing the whole thing, not just controlling the menus in there, then why is the PC memory matter? In other words, if the PC's job is to just load, suck it from the hard drive and fire it down to the OMAP, and the OMAP does the whole thing, then yeah, there shouldn't be any memory needed for that, because obviously you just load and then fire and then that's it. But that tells me something else. That something is the PC itself is doing the hard work. And as I said 10 years ago, the OMAP is nothing but a sound card and a mini controller. And you can see that here. So if I click OK, if I go to disk, for example, and go to factory, open up, and I go to preload.ksc here, and then try to load that up, you can see the interface is responsive. It's nice, it's working. Every time I click something, it's there. This is the interesting part, and this is the issue. So I'm just going to get my iPhone to record it in case the thing is not picking up. And here we have, you can see, sorry, just put the video on. Yeah, there we go. So here we go. Now you can see on the system is that the memory required is 739 in red, but the available is 60 meg only. I hope you can see that. Is it good lens? Yeah, that should be fine. Right, you see my point. So in essence, that memory we're talking about in here is literally the PC memory, not the OMAP memory. And I was actually quite right about this, but when people, when I spoke to this on a forum somewhere, they always said, no, you don't know what you're talking about, it's not right, this is not correct. And also, I think if we go to global in here, and which thing does, can't remember which one does the CPU and I think it was here, no? Oh, there we go. You see that? Memory, it says 3 gigabytes, or as the duck in Back to the Future, 3 gigawatts. So 3 gigabytes of memory is reported by the system, but the system only can see slightly less than that. And if I take you to what the PC has memory wise, so just going to break the shell, and I do cat proc slash mem info, you'll see here on the VM unlock total is 63896. So it's about nearly three quarters of a gig as total memory, and the chunk allocation is 14096, which means yeah, anyway, so we don't have enough memory to load the whole thing up, but the instrument will sound. There's nothing wrong so far with it. Now the thing is, if I try to click anything on the instrument, for example sampling, you can see it did send something, the buffer received it, but it's queuing it up. It's not, you know, it's waiting for the EV to come back. So if I go into foreground process, it's now clicked it there, and I can see that there. So now it's kind of doing the synchronization, anything that got missed, being filed up across, etc., etc. It's interesting to see all this communication going on, and by kind of hunting these down and then kind of logging this somewhere, you can design your own menus and tell it to do that stuff. It will work. I've tried it. It works. So, in other words, if I bring an iPad and give it, and put a listener on the PC and then tell the iPad to go and talk to the listener fire these commands, you can literally take your screens out into a different device like an iPad or PC or whatever it is, and then control this wirelessly remotely. It will work. There's nothing wrong with it. Which means the menus in here are all kind of nothing but when you click something, it sends it back to the PC. The PC do this stuff, and then this whole thing upwards to the other side. Now, that covers one side. And the other bit I wanted to talk about is this true? Let me just reboot the instruments. Let's just not wait for this whole thing to finish. And the other part I wanted to talk and confirm is what exactly are in these files. And as I said, I don't want to breach copyright. I don't want to do anything. So I'm not going to. I think when I spoke to my solicitors and stuff, if I make sure that these are not humanly readable files, then they should be fine. Reverse engineer. What I mean by that is if the code doesn't show as, for example, C, high level C language or something, and people kind of reverse engineer it. So what we'll do is slightly different. And I think if many people or anyone did this before in the past, is kind of visually show you what the files are all about. So this kind of should give you the impression of what the system has, or how the whole thing is put together inside. I think I got the wrong password. Yeah. Good. Okay, so if you go to the Kronos website, the Korg website, not the Kronos website, the Korg website, and you look for the updates for your Kronos or whatever instrument you have. There'll be two types of updates. Update to the main master instrument, which is the PC, literally in a way. That's the Linux stuff. And updates to the subsystem. The subsystem is the OMAP itself, and this is the what actually controls the interface in here, controls that stuff, and then it opens up and talks to the PC. One thing to mention: the OMAP does not control the keyboard, the keys in here, and my next video will show how that works 100%. Decompiled, and these bits in here. So the joystick and the two switches. That's the topic for the next video, as I said. But anyway, for now, I think, so far the stuff I've actually shown you might have been obvious and might have seen it in my previous video, or some of it might have seen in my previous, but the stuff I'm about to show you now are a little different. So when you, as I said, go to Korg's website, download the files, you'll end up in something like this. Right, and you can see, for example, you got the subsystem, Kronos V whatever stuff, and you got the updates, the tar file. You can just untar it and all that kind of stuff. So the two things, the Kronos update tar, this is the OS itself. That's what you update the OS with, and down here is the subsystem. And if you have one way managed to reverse engineer an instrument and look inside it, you'll probably see under Korg there will be what is going on. Oh, I hope that doesn't stop my video again. 1 second. It's 3 a.m. What's going on? Yeah, ignore me, sorry. Right, sorry. Yeah, anyway. 3:30 a.m. For nearly 24. Anyway, so yeah, the when you look into that stuff, if you reverse engineer the instrument or manage to break into the encryption, you'll see the OA.ko. You'll see the EVA also, the stuff there. So these are the files. Obviously, we're not listing the contents of the file. We're just showing you there are files when you when you kind of break the encryption of the instrument. So without further ado, let me just show you now the interesting parts. As you can see, the subsystem in the Kronos, this is unzipped, the VSB file, is 917760. And you think, that code is quite big, and it probably will contain the whole menus inside and all that kind of stuff. But does it really? If it does, then there should be graphics, things like the piano sound or image or buttons or stuff there that you can visually see. And because the files are actually all in binary, you really can't tell. So what I developed is a little thing to yeah, okay. No, let's not do that one. Yeah, that's it, file to screen. Yeah, we'll do, which one is it? We said the subsystem, didn't we? Yeah. So the subsystem, when you download from Korg, it will contain the code for this one. So when you power up, this is the graphical representation of the file. So you can see, without having to reverse engineer the file or put it in a text format, clearly the file is, by just looking at the contents, you see the 30% or the 20% of the file is the code or the stuff that loads up, and this what works. This what makes the thing heartbeats and control talks to PC and stuff. They can see the above stuff is just literally nothing but codes, and you can tell by looking at the top bit. The middle, the bottom section is that little white here. That means the file has got nothing, useful. It's just all zeros or ones or empty or FF basically. It's just nothing in there. The most section of the part, or the biggest section, is that little thing that's got Korg in it, or lots of Korgs inside. But that you don't know, and the tool I designed is quite interesting because obviously the resolution on the screen on here is 800 by 600, but on this system is actually 1280 by 1024, and it's probably not the same structure, not the same width and height and stuff. So what I've done is the tool I've designed is kind of, if I keep pressing, just to take it down a little bit. So I'm actually shrinking it down and telling the system. So I'm just going to hold the key there. And here's where it gets interesting. Nearly halfway, nearly there almost. And I think we get in there now. And here we go. So let's just shift that a little bit here. How's that? So now I'm just holding up the key just to do an offset, so I can just center it in the middle of the screen. So every time I press the keys, 1 bit or 1 pixel moves. Right, now that's the stuff inside the file. And funny enough, by looking at the screen, does that remind you of something? No. Anyway, you see that is the screen that you have here. So the subsystem code is 60-70% of it is literally the image and nothing, because the firmware has nothing at the end, and 20% only have the stuff, which only looks like code. I mean, I can see on top there where, see, that bit here has some buttons and some stuff to click, but that's just minor. I think this is it's just stuff. So in other words, the subsystem is a sound card, which runs the stuff on the back. B is the controller for the menus, and yeah, so that's what I literally wanted to show you that today, just to be as close as possible. Now, looking at this, so I'm just going to exit now. If I load up another file here, so let's just see. Let's load up the Kronos update itself.tar. And now, looking at this file, do you see, I mean, just by looking at the file visually like this, you can probably tell most of the screens are actually here, not on the other side. So if I, kind of do that shifting, you will see that. Let's just look into that one here. So you see that there. So I'm not reverse engineering the file. I'm just showing the code, what it looks like. I think that's a close one. Okay, so let's just take the page down, and now see that under the screen there, yeah. And this is one of the interesting ones. So all I'm doing is pretty much dumping the stuff on screen, and just to show you a visual representation of what the files looks like. So not reverse engineering. Well, it is not really, but I'm not showing you codes and stuff. But you can see, for example, here, these are the makeup of the buttons, and you can see, for example, on top there, the sliders. So yeah, it's let's see what that is. Yeah, I think these are little boxes there. There we go. See if we can do. Yeah, you see, by just shifting this stuff, you can tell these are all objects to load up the system. And in essence, the EVA file and the stuff inside are the ones that loads up the screen. So yeah, I mean, I can there's tons of stuff in here. I can just take this all day. And if I look at the unencrypted EVA file, and if I do this, for example, yeah, this is the EVA itself, this unencrypted, but look at the top there. Anyway, let's just move on. Take it a bit down. That's EVA. Yeah, see that? It doesn't look like anything, but if I do this, you can see there are objects in there. They're probably Qt objects. I know it's mostly code, so let's just take it to a different. Oh, that's another screen. That's an interesting one. There we go. You know, sliders, buttons, and stuff like that. Yeah, but you can see, you know, you can tell from a representation, visually, what the file looks like. So it's not, you know, yeah, there. This is it. Interesting. And these are samples. Maybe some audio stuff as well. But yeah, see that top bit there. So all to do is synchronization. Yeah, see that? There's objects in here. Yeah, you can see there. And if I keep scrolling down, obviously a button, when you write a little button, for example, the button, for example, let's say it's about 10 pixels and 5 pixels wide. So for 10 pixels, to compress the button, obviously they're not going to have the whole thing running like this in a file. They have the line, and then the line next to it, and the line next to it, and then when you come to load it up, it goes and it loads the first line there, the second line comes on underneath, and then so on. That's exactly what I'm doing here too. So that, for example, is another object or another screen. That's another stuff. So you can see, you know, the EVA file is it's got a lot of that stuff in here, which tells me one thing. You know, confirms that it is the one EVA and OA. Let's look into the OA as well, just to in case. Oh. OA. Sorry. Oh, it's Kronos. Sorry, what was I doing? Yeah. So this is the OA file, the Oasis file, and the Oasis file, ladies and gentlemen, it's similar stuff. That's the beginning of it, and I don't expect to have anything on that screen because that's the beginning and all this stuff and the file system. But going down the line like this, look, it's got objects in there, visual objects inside, and whether or not that is the piano keyboard when you go up and down, I don't know, but it's clear that these are images embedded within the system. So you can see, you know, part of it is screens, part of it is, you know, corrections, and all the stuff is actually inside the files, the PC files. So that by itself, I think we're going, you know, coming to an hour, and yeah. So what I want to talk about is the contents of these files, and whether or not who's doing the loading up and speeding things up. So going down the line, although I did work on the Kronos and get to that far, the items that's pending at the moment, so the ones that's pending it right now, even though I've got to power up, the instrument's going to power up fine, but because I have, I'm actually doing a logging on the interface, and I got debug mode on, Maybe that has something to do with what I'm about to show you now. We'll just wait for it to load. The next video, I know this video might be a little dry, a little, not extremely interesting, but it's just a sign for me to say I'm back, I'm working on this. I don't know how far I will go. I don't know if, yeah, it's just a hobby. It's just something I like to do, not a business, not something paid. It can take as much time as it takes. Will it go further or not? I have no idea. It really depends. Yeah, we're loading up. Yeah, finally. Hallelujah. Right, so we're loading up. Fine, good. The system is loaded up fine. What you haven't seen yet is, does it work? It does, but not quite. So if I see the piano, as if the pulses that's coming out of the piano aren't really fast enough. Or the system can't really cope with sending too much data because A, I'm doing lots of logs. B, it's still a development environment, and C, it is a it could be something I need to look into more, and this is something I'm actually working on now. So if I take you to Combi, for example, it'll be more obvious in here. Yeah, Combi is up, and if I power up these two things to get the drum running, and I press something, see that? It's not there. By the way, if you have a similar problem on your instrument, it is not a hardware problem, it is a software problem. It's to do with timing, synchronization between the PC and the thingy. Literally the PC is not fast enough, or the OS content is not fast enough to load this whole thing up and running. And that's the issue at the moment. That's why when we kind of overload it with stuff, it will choke. So that is something I'm actually working on. And I've got, not the next video, the video after probably, will tackle this more. But the next video I'm working on will it's going to be a lot more interesting than this one, I promise you. So if I reboot the instrument, why am I showing it's a software problem? Because the instrument does work. I'll just reboot the instrument now. Yeah. Yeah. Good. Notice when it rebooted, the PC went down first. The screen kept in there, but the audio got cut off before the screen gone on. Was dead, and that is a sign that what I said is right. It is the PC. The whole thing is happening on the PC, and the Kronos or the OMAP is just a sound card. So I'm going to power up differently this time, and you will see that the instrument will work fine without the logging bit. So that's native, without logging and without stuff, my stuff that I added there. You'll see the instrument works absolutely fine. I haven't touched it, I haven't changed any hardware things inside. See, if the PC is loading that stuff up, then why does it take that time? It honestly, no disrespect, but it's not good coding. At the end of the day, you got tons of other stuff to do. You can load it differently, and you can just cut it down, encrypt it if you like. It's fine, but the way this is loading up, it just doesn't make sense. It's just way too slow. It's probably all done by custom made files and stuff like that, which not really paid attention into technologies and other stuff that can be done to speed up that kind of loading up. I mean, it's credit to Korg. The instrument works, but it's way too slow. That's the problem. Loading up is just a nightmare. I just don't like the way it loads, and because the way they've done it, it's hardly any room for improvement with the existing OS, and that's what that's what I'm actually trying to work on at the moment. So now this is natively working. You can see with the PC side or the OS side being fast enough, it's loading up fine. For the combi, so I'm just gonna take that down. Everyone's asleep upstairs. Yeah, but you can see the system does work. There's nothing wrong with it. It's just because of the OS and the debugging and all that kind of stuff with the symbols going in, it is slower, and because of that slowness, it can't cope with the system. So anyway, my next video that I promised my Facebook people that I will be posting was meant to be this one, but there is no time. It's nearly 1 hour. I don't want to have the video going to 3 or 4 hours, so I'm gonna cut the video or end it here. Thank you for watching, and well, I'll see you in the next video about the Kronos again. I'd love to make more music on the montage. I do. It's just I had no time. But anyway, I need to kind of shut my stuff down and go to sleep because it's now 4 a.m. Got work to do today. Funny enough. So yeah, thanks for watching, and we'll see you in the next video. Have a good day.